Okay, third attempt. I've lost this video twice now, so I'm going to do this again one more time. And what's going to happen is I'm going to do 4 pages, and you're going to end up with like 10-minute videos, and there might be 3 or 4 of them, I don't know. So here are the steps for solving and doing an integral by substitution. And when you do that, right now I would say I don't love substitution, but eventually, by the time you get through Calc 2, I do love substitution. So I just need to find the love again. It's broken my heart twice right now when it doesn't save this video. So these are the steps that you'd follow, and you just have to pick something to set equal to u. And you say, well, what do I do to do that? That's the big thing. I don't understand what to do. You've got to anticipate the derivative, but then here's some guidelines over here. You can let the trig function, if it's one of the big 6, let the trig function just use the argument. So if it's sine of 6x, u equals 6x. If it's the cosecant of 5x, cotangent of 5x, let u be equal to 5x. Choose the higher powered or degreed polynomial. If it's an exponential function, do the entire exponential function. It doesn't matter whether it's a 7 to the x or e to the x. Some people may suggest a different strategy, but if you don't want to make a silly mistake, just do the entire function. And if we have inverse trig functions, which we'll talk about eventually, well, inverse trig function formulas just have an x squared. So if you have any other number, like a 3x squared, you got to let u be equal to 3x. So let's see, that's the 3rd time I've underlined that. All right, so here's an example of substitution, one strategy, and there's some things I'm going to erase and some things I'm not going to erase. And so when you do your substitution, you choose the higher powered degreed polynomial plus the one that's raised to the power as well. You don't want to do algebra. I think I said that on the first video that didn't make it. You don't want to raise it to the 7th power, and you don't want to distribute 6x in there and still have it to the 7th power, because then you're going to algebra jail. All right, take the derivative, and you can go through this whole process right here, taking the derivative implicitly. But there's a shorter way to do it, and again, 3rd time I've underlined this. You could just take the derivative of u, which is a 1 du, and then take the derivative of x squared plus 5, which is 2x dx. Or you can just go ahead and go directly to that instead of going through this whole process. All right, the next step then is for us to start substituting. And so I tried to do the colors, and I left the colors in green and then in red that you can see. The 6x dx 3 du gets substituted for. Well, where did the 6x come from? We multiplied both sides by a 3 so we could make that match. It's one of the strategies of multiplying by some number. Look at that, 3 check marks, if you don't believe me. All right, so after you do your substitution, you end up with this expression. And again, you can just recopy the 3 and take the antiderivative of that, which is going to be u to the 8th. And so divided by an 8, and you end up with 3/8 times 1/8, and you end up with this as your answer. This is one way to do a problem. The next page has another way to do the same problem. All right, the way that this is different, and I'm going to erase some of this, please. Is you can see some of the things that are the colors, but what you're going to do differently is right here. You're going to multiply both sides by a half, and that's this step. And the reason you're doing that is so you get an x dx so that you can substitute for that. There you go, 3 colors again. You can put a 1/2 dx in place of that, or 1/2 du, I mean. So here's the 1/2, and here's the du put in place of that. The rest of it, well, the 6 is still there because you didn't do anything with it. You just recopied that, and then you substituted for the x squared plus 5, and that's where you got the u to the 7th, u, and then raised to the 7th. You integrate that just like we did the last time, and there's your answer. All right, this one, well, big 6, underline 3 times. If you have a big 6 function, sine, cosine, secant, tangent, cosecant, cotangent, secant squared, or cosecant squared, then you just want to let u to be equal to whatever the heck the argument is that you can see right here. Take the derivative, you can do your substitution, and it turns this thing into a nice 1/8 sine of u du. And then you integrate that, and that gives you cosine, but you got to remember the negative. 3 underlines again. And you simplify that, and you end up with, and resubstitute, you get this as your answer right here. I'm going to do one more page and hope to God that it records. All right, so here's a big 6 problem again, because it's secant tangent. And so you just let u to be equal to the argument. You get 1/2 dx, but then you multiply both sides by 2, so you can substitute for that. And then you just put the u in place of the 1/2, and you integrate that, and you just recopy the 2. Integration of the secant tangent is going to be a secant of the argument, and then you resubstitute, and there's your answer. All right, the last one that I'm going to do before I try to save this again is we're going to let u to be equal to a higher powered polynomial, if I could say it for the 3rd time. Here it is, and we're going to take the derivative, and we're going to end up with this 3x squared plus 9, but it's not what you see right here, so we're going to multiply by 1/3. Now it's what you see, and so I can substitute that in place of the stuff that's here and here, and so I have 1/3 du, and I can substitute in the green part for this right here, and so I have 1/3 u to the negative 7. Don't forget that when you add a 1 to the negative 7, you end up with a negative 6. So you get u to the negative 6 divided by a negative 6, multiply that, and resubstitute that, and there's your answer. All right, please jot whatever down you want, because I'm about to try to save this, or else I might jump out the window.